The students, in our last video, we have discussed some of the important questions from the chapter Relations and Functions. So today we will discuss some more questions from the same chapter here, which comes under CET and JEE. The first problem is, if capital N be the set of natural numbers, consider f is a mapping from n to n such that f of x is equal to 2x for all x belongs to n, then f is. So these are the four options. So to answer this question, we must know what you mean by 1, 1, onto, into and many one. So 1, 1 means f is a mapping from n to n. So n is the domain set and this n is the codomain set. So every element, distinct elements of this domain set has distinct images in a codomain set. Then we say that function is 1, 1. Onto means every element of this codomain set must have at least one pre-image in a domain set, that is known as the onto. In other words, a function is said to be onto if the codomain set is nothing but a range set. So into means there is at least one element of this codomain set which does not have any pre-images in a domain set. So that is the definition of into. So many one means, suppose there are two elements in a domain set which have same image in a codomain set. Two different elements of the domain set which have same image in a codomain set, then we say that that mapping is a many one mapping. So using this definition, we have to check whether the function is 1, 1, onto or any other form here. So to define 1, 1, we already defined that distinct elements of the set A, domain set, which have distinct images. That means suppose f of x1 equal to f of x2 implies x1 equal to x2. So this is one more definition of 1, 1. So here we have the function f of x is equal to 2x. So f of x1. So f of x1 is nothing but 2x1. 2x1 is equal to 2x2. So I can cancel 2. This is a positive number, which implies you will get x1 is equal to x2. So clearly this is true for all x belongs to natural number. So meaning it the function is 1, 1. So the option is either the option A, option B. So in the option C, many one. This is not the case here. So we can neglect this one and we can also neglect this one here. Then we check with the onto. To check the onto, with definition is take one element y in a codomain set. If there exists one element x in a domain set n such that f of x is equal to y, then we say that f is onto. So here there is one element x. We can write x as y divided by 2. That does not belongs to n, because n is a set of natural number. So y by 2 is not a natural number. So clearly this is not onto. Therefore f is into. Function is 1, 1 and the function is into. Therefore option B here. The second question will be, let star be a binary operation on set of integers defined by a star b is equal to 2a plus b minus 3. Then the value of 3 star 4 is. So using this definition, we have to find the value. So we know that directly substitute the value, given that a star b is 2a plus b minus 3. So in place of a we put 3, in place of b we write 4. Substitute the values after simplification. You will get 7. This is the simple question. So answer will be option C. The third question is, let star be a binary operation on Q. Q is set of rationals defined by A star B is equal to 3AB divided by 5. Then star is. You have to check whether star is commutative or associative or both commutative and associative. That is, both A and B means both commutative and associative, and none of this. We know the definition of the commutative and associative. We check here. So this is given A star B is equal to 3AB divided by 5. So commutative means A star B is equal to B star A. That is symmetric here. So check here. A star B, by definition this is 3AB divided by 5. B star A is nothing but 3BA divided by 5. So both are equal. Therefore this is commutative. Okay, so that's one. Now we have to check the associative. If it is associative, then the option will be option C here. Let's check. So associative, you know the definition, A star B star C is equal to A star B star C. By applying the definition after simplification, you will get 9ABC divided by 25, and here also 9ABC by 25. So these two are equal, left hand side equal to right hand side, hence this is associative. Therefore the answer is option C. The fourth one is on Q minus 1, that is set of all rational numbers other than 1, such that A star B is equal to A plus B minus AB, the identity element is. So we have to find the identity element of this binary operation star defined by A plus B minus AB. So if I consider E is an identity element, then for all A belongs to the given set of all rational number other than 1, the definition is A star E is equal to A. So this will be the definition of the identity element in case of binary operation. Given that A star B is equal to A plus B minus AB, so in place of this we replace this definition, we'll get A plus E minus AE equal to A. By the law of cancellation, we can cancel A. Then we'll get E minus AE equal to 0, or you can take E as a common term, then 1 minus A is equal to 0. So 1 minus A equal to 0. So this cannot be 0. 1 minus A cannot be 0 because A is not equal to 1. If A is equal to 1, that is the only possibility that this term 0. But A belongs to this set which does not have the element 1. Therefore, the only possibility is E is equal to 0. That is option A here. The next question is, if the set A contains 5 elements and the set B contains 6 elements, then the number of 1, 1 and onto mappings from A to B is. We have to check these 4 options. We have two methods. One is a time saving results. Using that we can easily find out the answer. And one more is with the explanation here. So now for a function to be 1, 1, all the elements of domain set. So in this example, A is a domain set and B is the codomain set. All the elements of the domain set should have unique image in a codomain set here. So here A has 5 elements, can be mapped into 5 distinct elements of B. So which implies F is 1, 1. But B has 6 elements. That means there is one element in B which does not have any pre-image in E. That implies f is not onto. That means in the first case, if f is 1, 1, then f is not onto if the number of elements of set A is 5 and number of elements of set B is 6 here. In other words, if all the elements of B are mapped into all the 5 elements of A, then we can observe that there will be at least 2 elements of B which have same pre-image in E. That indicates f is not 1, 1. Thus, f cannot be 1, 1 if it is onto. So the conclusion is there cannot be any 1, 1 and onto mapping from A to B if number of elements of this A is not equal to number of elements of this B here. So using this concept we write. So here suppose n of A has P elements and n of B has Q elements. Then the number of 1, 1 and onto mapping from A to B is Q factorial if n of A is equal to n of B. And the number of 1, 1 and onto mapping from A to B is 0. There is no mapping if n of A is not equal to n of B. So clearly n of A is not equal to n of B. Therefore, there is no 1, 1 and onto mapping from A to B here. Therefore, the answer is 0. That is option C. Next question will be, let R be the relation in the set having the elements 1, 2, 3, 4 given by R. The relation R having the elements, these are the elements here. So choose the correct answer. That is, we have to check whether R is reflexive and symmetric but not transitive. Second option is R is reflexive and transitive but not symmetric. R is symmetric and transitive but not reflexive, and the last one is R is an equivalence relation. So first we take the relation. So relation R having these elements. You know that reflexive means any relation is reflexive implies for an element A, order pair A, A belongs to the relation R. So there are 4 elements. So order pair 1, 1, 2, 2, 3, 3, 4, 4 should belong to relation R. Yes. So it has 1, 1, 2, 2, 3, 3 and 4, 4. That is not in the given same order. Their order is different here. So this is reflexive. So we cannot control, but we can cancel the option C because option C says that this is not a reflexive. So I can cancel the option C. Next, go to this symmetric. Order pair 1, 2 is there, but order pair 2, 1 does not belong to this relation R here. So according to the definition of symmetric, R is not a symmetric relation. So clearly first one is not the option because here the first one says R is symmetric, so this is not the option, and the fourth one is also not the option. Clearly they mentioned in the option B R is reflexive and transitive but not symmetric. To choose this one, first you have to consider the transitive, but since you know that R is not a symmetric, clearly we can cancel A and D. The remaining option is B. So without checking the transitivity, you can choose the answer here. Therefore, option B. The seventh one will be, let R be the relation in the set of natural numbers given by A minus A is equal to B minus 2 and B can take the values greater than 6. So choose the correct answers. That means this order pair belongs to the relation either this one or this, or order pair 8, 7 belongs to the relation. So for that, first we have to write the relation R, that is for B greater than 6 here. So n is a natural number, you can take the values 1 to infinity. Since B is greater than 6, we can start with 7. So if B is 7, value of A is equal to 7 minus 2, 5. So the First order pair is 5, 7. Clearly the second order pair is 6, 8. Third order pair is 7, 9. It continues. So here itself you can observe there are 4 options. First one is not there, second one is not there. So clearly third one will be the answer here. So answer will be option C, order pair 6, 8 belongs to relation R. The 8th question. Let A is having the element 1, 2, 3. A is a set having the element 1, 2, 3. Then the number of relations containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. We have to find the number of relations, not the relation. We want the number of relation. So first we have to try to write the relation which is reflexive and symmetric but not transitive. You know the definition. So reflexive, there are 3 elements. So 1, 1, 2, 2, 3, 3 belongs. Therefore R is reflexive. Then symmetric. Symmetric means if order pair A, B belongs to the relation R, then the order pair B, A also should belongs to the relation R. Let's check here. So 1, 2 belongs, therefore order pair 2, 1 also belongs to the relation R. If I take these two, 1, 3 and 3, 1, so belongs to the relation R. So clearly R is symmetric. And in this case, this is not transitive. As I'll consider this order pair 2, 1 and another order pair 1, 3. We know the definition of the transitivity, that is A, B and B, C belongs to the relation R. Then A, C also belongs to the relation R. That means order pair 2, 3. But 2, 3 does not belong to this relation R. Therefore, this is the relation. There is no other relation which is reflexive, symmetric but not transitive. There is only one relation. Therefore, the number of relation containing 1, 2 and 1, 3 and satisfies this condition is only this relation. Therefore, answer will be option A. The next one will be, let A having the elements 1, 2, 3. Then the number of equivalence relation containing the order pair 1, 2. So we have to find the number of equivalence relation and which is having the element 1, 2. So these are the options here. So we know that a set having 3 elements, then the number of equivalence relation is 5. Maximum number of equivalence relation on a set having 3 elements is 5 here. So we can list the relation, equivalence relation that is having order pair 1, 2 as an element. So we listed 2 relations. So only these 2 relations, out of 5 relations, only these 2 relations are equivalence and having the element 1, 2 here. Therefore, the number of equivalence relation containing the order pair 1, 2 is 2. That is answer option B. 10th one will be the number of binary operations on the set having the elements A, B are. That is a set having 2 elements. You have to find the number of binary operations. So here we know that the number of binary operations on the set having n elements is n to the power n square. This is a time saving results here. The number of binary operations on a set having n elements is n to the power n square. And hence here the set having 2 elements, therefore value of n is 2. So 2 to the power 2 square is 4. 2 to the power 4. 2 to the power 4 is 16. Therefore answer is option B. The next few questions we are going to discuss here comes in JEE. So in a JEE, we can expect 1 or 2 questions from the chapter Relations and Functions. So this type of questions come across in JEE here. So let's see some questions. For x belongs to set of all real number other than 0, 1. Let f1 of x, f2 of x and f3 of x are 3 functions defined on this real number other than 0, 1. So that is defined on this set. If a function j of x satisfies this condition, that is the composition of these 3, then we have to find what is j of x here. Out of these 4, we have to find which one is the correct option. We know the definition here. F2 composite j of composite f1 of x is nothing but f2 of j of f1 of x here. First we simplify the innermost function, then move to the next one and the outermost function. So f1 of x is 1 divided by x here. Therefore f2 of j of, instead of f1 of x, if I write 1 by x, and the right hand side is f3 of x, that is nothing but 1 divided by 1 minus x. J of 1 by x, so this is unknown function, so treat this as f2 of the variable. f2 of the variable x is 1 minus x, therefore f2 of the j of 1 by x is 1 minus j of 1 by x, and that is equal to the right hand side here. So after simplification, we will get j of 1 by x is equal to minus x divided by 1 minus x. Now we want j of x. Here we got j of 1 by x. So we replace 1 by x on both sides, on the left hand side as well as right hand side. So here if I write 1 by x instead of 1 by x, here instead of x we have to write 1 by x. So after simplification, we will get j of x is equal to 1 divided by 1 minus x. So 1 divided by 1 minus x is nothing but the function f3 of x. Therefore, option is answer C. The next one is, let A be a set having the element set of all x belongs to the real number such that x is not a positive integer. Define a function f from a to r as f of x is equal to 2x divided by 1 minus x. Then f is, x is not a positive integer means x may be a negative number or 0, negative integer or 0 here. So we have to check whether f is surjective but not injective. So first option, second option injective but not surjective, not injective and neither injective nor surjective. So we know that injective is 1 1, surjective means onto here. So we know the definition of 1 1 and onto. Using that we check what is the behavior of this function. So f of x is 2x divided by 1 minus x. So since x is not a positive integer, x can take the value 0. For x equal to 0, what is the value of f of x? F of x is equal to 0 here. So for x less than 0, for all the negative values, for x less than 0, f of x gets the value minus 2, 0. That is minimum value is minus 2. We can reach up to 0 here. Minus 2 to 0. It not exceeds these numbers here. So f of x is not onto, as the range of this function is half open interval minus 2 to 0. 0 is included because for x equal to 0, f of x is 0. So we know that the function f from a to r is said to be onto if codomain set R is nothing but range set. But here the range set is only this interval and the codomain set is set of all real number. Therefore, the function is not onto here. Now we check the injectivity of the function. By definition, f of x1 equal to f of x2. So this is 2x1 by 1 minus x1 equal to 2x2 by 1 minus x2 by cross multiplication, and after the simplification we got x1 is equal to x2. So this satisfies the definition of 1, hence the function is injective. So function is injective but not surjective. Therefore answer will be option B. The next question is, let f is a mapping from R to R defined by f of x is equal to x divided by 1 plus x square and x belongs to set of all real number. Then the range of f is. So we have the function f of x is x divided by 1 plus x square. So we find the value of this function f of x for all real number, because domain of this function is set of all real number. So at x equal to 0, clearly f of x is equal to 0. And for all negative values, for all negative real numbers, f of x belongs to the interval half of closed interval minus 1 by 2 to 0. And when x greater than 0, it is for all positive real number, f of x belongs to this interval here. So at x equal to 0, f of x is 0. For all negative value, this will be the range, and for all positive value, this is the range. Therefore, the range of the function together is closed interval minus 1 by 2 to plus 1 by 2. That is answer option C. The next one is, if f of x plus 2 times f of 1 minus x is equal to x square plus 2 for all x belongs to R, then f of x is given as. So these are the options here. We have to simplify here. So this is given. We taken this as 1. Now if I replace x by 1 minus x in equation 1, we will get equation 2. So we are replacing x by 1 minus x. Next we are simplifying this form, that is, for this equation 1 we are going to subtract this equation 2, but before that we are multiplying equation 2 by 2. So f of x plus 2 times f of 1 minus x minus 2 times equation 2 is multiplied by 2. In the similar manner, in the right hand side of equation 2 is multiplied by 2. So after simplification you will get minus 3 times f of x is equal to this one, or 3 times f of x is equal to x square minus 4x plus 4. So f of x is nothing but x square minus 4x plus 4 is nothing but x minus 2 whole square and divided by 3. Therefore, answer is option A. The last question of this session will be, if the function f and g are defined from set of all real number to set of all real number such that f of x gets the value 0 when x is rational and gets x when x is irrational, and g of x gets the value 0 when x is irrational and g of x gets the value x when x is rational, then you have to find what is f minus g of x. So these are the option here. To find this, for simplicity, we will take f minus g of x as h of x. So by definition, f minus g of x is f of x minus g of x. So according to the definition of this f of x and g of x is irrational. When x is irrational, f of x equal to x. When x is rational, f of x equal to 0. So we can neglect this one, because for all rational number, f of x gets the value 0. Here also for all irrational number, g of x gets the value 0. Now we are combining these two. Therefore, f of x minus g of x gets the value x when x is irrational and here gets the value, g of x gets the value x when x is rational. So this minus sign because of this. So h of x is defined in this way. And note that the function is clearly 1 1 here. The function h of x is 1 1. That is, for every irrational number there is a number, and for every rational number there is a negative number. For every irrational number there is a positive number, and for every rational number, distinct rational number, there is a distinct negative number. So clearly h of x is negative on 1. Similarly, this h of x is on 2. So we know the definition. If the codomain set is a range set, then the function is on 2. So in the codomain set, we'll get all the rational number as well as irrational number. For all the rational number, there is a negative number. If I take the rational number, you will get the negative rational number. For all the irrational number, there is a pre-image positive irrational number. So for every element of this codomain set R has a pre-image in set of real number. So the function h of x is onto. That means function is both 1 1 and onto. That is option A here. Thank you.